Good morning students, this is Joy Varghese from Uncovering Chemistry. Today in video 13, that is we are going to discuss about preparation of sulfuric acid, which you can see on board what we say, preparation of sulfuric acid. Now in this there is a process, what we call it as a contact process. Now this process involves 3 steps of preparation, so that all things we are going to discuss in this video. Okay, preparation of sulfuric acid. Okay, now just a minute. Now preparation of sulfuric acid by contact process involves 3 steps. 3 steps. Okay. Now in this, when we say step 1, the sulfide ores, what we call, that is burning of sulfide ore in air. Burning of sulfide ore. There is copper sulfide or like that, many ores are there of sulfide, what we say. The burning of sulfide ore in air to obtain SO2, what we call, to obtain SO2 gas. Obtain SO2 gas, and this SO2 gas is purified in next step. Clear? So this is what we call it as step 1, that is sulfide ores are burned to give SO2 gas, and this SO2 is purified for the next step. Understood? Now in step 2, when we say step 2, after producing this SO2 gas, step 2, what we say, this is the most important step. What we call it as, this is the most important step in which SO2 is converted to SO3. SO2 is converted to SO3. SO2 is converted to SO3 with the help of catalyst. SO2 is converted to SO3 with the help of catalyst, and catalyst, that is vanadium pentoxide, V2O5. Understood? So SO2 plus O2 in presence of V2O5, V2O5 gets converted into 2SO3. Okay, SO2 plus O2 in presence of vanadium pentoxide gets converted into what we call it as SO3. Okay, now here you have to remember that this is a reversible step, so you have to be careful with this. Now in step 3, what we call, that is step 3. When we talk about this, in step 3, the absorption of SO2 in H2SO4 to give what? Oleum. What is the word? Absorption of SO2, okay, in absorption of SO3 in H2SO4 to give oleum. Oleum formula H2S2O7. Understood? So step 3 is absorption of SO3 in H2SO4 to give oleum, that is SO3 plus H2SO4, what we call it as, gives H2S2O7. This one we call it as oleum or fuming. What is the word? Fuming sulfuric acid. Clear? Oleum, what we say. Now after that, dilution of this oleum, when we call about dilution of this oleum, will give you what it will give? It will give different percentage of what we call it as sulfuric acid. That I write here. So from this step 3, this point you can write down after step 3. That is dilution. Means from here you have to continue from here. That is dilution of oleum. That is H2S2O7. That is dilution of oleum H2S2O7 with water. With water gives H2SO4. Understood? Now the what we call it as the sulfuric acid obtained. You can remember this. The sulfuric acid obtained by contact process. Process is now you must have heard about this. What we call it as the sulfuric acid obtained by contact process is what we call it as almost 98% pure. 98% pure. Is it clear? Octane is almost about 98% pure. Now this was all about what we call it as preparation in contact process. Now we will discuss about the next part. What is that is the most important step is catalytic oxidation. So that I will write here. You can write down this in your fair book. This can be so actually this is not there for board exam for 2021. Okay, but for your knowledge it is important because properties are there of sulfuric acid. Okay, in your board exam. So it will come after this. So first of all you have to understand what is this. Okay. Now adsorption of SO3 in H2SO4, what we saw, that is step 2. The most important step. Now what is the most important step in this case? The most important step is the catalytic oxidation of oxidation of what we call it as SO2 and with O2. Catalytic oxidation of SO2, what we call with O2 in presence of V2O5. V2O5 is what? It is vanadium pentoxide. What is it? Vanadium pentoxide. Understood? This is the most important step that what we have seen. That is SO2 plus O2 gives you what? SO3, like this. In presence of vanadium pentoxide as a catalyst. Okay. Now this one, what we say, it's a reversible reaction. So don't forget to write this reverse arrow. And the enthalpy of reaction, what we say, enthalpy of reaction is equal to minus 196.6 kilojoule mole inverse. Understood? This is the enthalpy. Now this reaction is reversible and exothermic. Right? Now, as it is an exothermic reaction, what happened? Too much raising the temperature too high is not required. It is favorable. Since it is what you call exothermic, low temperature is favorable for maximum yield. Since it is exothermic, clear? Low temperature, because in exothermic reaction we don't heat the mixture more. So since this reaction is exothermic, low temperature is favorable for maximum yield. Clear? Maximum yield means for maximum production. But we know as we decrease the temperature, the rate of reaction decreases. Understood? So we cannot decrease the temperature much. Clear? So what we say here, but temperature, remember this thing, but temperature should temperature, what we say, but the temperature should not be very low, otherwise rate of reaction decreases. Understood? So don't reduce the temperature too much. Understood? Now as this thing happens, so that's why we use a catalyst to get this, what we say, because it increases the rate of reaction, what we say. Since okay, now till here. Now there are certain other things in this what we have discussed in preparation of contact process. That is what we saw already. You must not decrease the temperature too much, otherwise rate of reaction will become low. Now since the number of gaseous component decreases in forward direction, high pressure, this also you can write, since the gaseous means both are gaseous component, since the gaseous component, what we say, components decrease in, that is this I am talking about, because more gas is on this side, is decrease in forward direction, the increase in pressure, or what we call it as, the word is what, the high pressure, of the high pressure also in direction, high pressure, what we call, is also favor, high pressure also favor, what we call it as, favors maximum yield or production. This you can remember, because of this here 3 component, and here on that forward direction there are only 2 component, right? So if you want, according to Le-Chatelier principle, so if you decrease, what we call it as, the pressure in forward direction, what will happen? It will go back and you will get more, this will react and you will get to keep on reversing and forwarding this reaction, you will get more yield, what we call. Understood? So remember this thing. Now actual temperature is kept, what we call it as, 720 K, and pressure is kept, what we call it as, 2 bar. Actual temperature, this I will rub it. Okay. Now in this case, actual temperature is kept 720 Kelvin. Actual temperature is kept, what we call it as, 720 Kelvin, and the pressure is kept 2 bar. Understood? So that will be helpful in this reaction. Okay. Since V2O5 is what we call solid catalyst and all other component are gaseous, this is an example of heterogeneous catalysis. Understood? So if you didn't understand, see, it is like this: SO2 plus O2 in presence of V2O5. Now V2O5 is solid, and these all are what we call it as, these all are gaseous state. Okay, so these all are in gaseous and this is in solid. So that's why this is an example of heterogeneous. What is the word? Heterogeneous, what we call it, reaction. Understood? So this is an example of heterogeneous reaction of catalysis. Understood? Okay, now I think it is balanced. Okay. So this was all about what we call it as preparation of what we call it as sulfuric acid. In the next we will be discussing about properties, that is physical and chemical properties of sulfuric acid, which is there in your board exam. Okay, and uses also we will discuss. Okay, till then we will stop this video. Next time we will be continuing with the next video. Thank you very much.